Good afternoon, everyone. This is Rich Medairos broadcasting for Taco Comfort Solutions. Today is Taco Tuesday, and today's topic is all about the HSS software. This is one of the most popular software packages that's in the market today. It allows you to design piping systems, hydronic piping systems specifically, in a fraction of the time that it would take you to do it manually. In a moment, I'm going to turn it over to Brett Zerba, who is our presenter today. Just a quick note about myself and about the company. Again, my name is Rich Medairos. I'm a mechanical engineer. I specialize in the engineering and design of HVAC systems. I am a registered professional engineer in a couple of states, and I've been with Taco for just about 8 years. Actually, it's 8 years this week, now that I think of it.
Wow. That was
Time
a fast
flies.
8 years, my friend Rich.
I know, that was, I feel like I just walked in the door yesterday. A couple of quick things for you, that for the folks out there that haven't been on our Taco Tuesday webinars, is that Taco is a manufacturing company headquartered in Cranston, Rhode Island. We are celebrating our 100th year anniversary this year, although our physical celebrations have been postponed until next year because of the COVID virus. Company is family owned by the White family, and specifically John Hazen White Jr. is the current owner of Taco. And John is very fortunate to have Cheryl Merchant as our global CEO, and Cheryl and her senior management team have done a fantastic job of navigating through this very difficult time period. So we're very proud of the job that Cheryl and her senior management team have done for us. This is really great stuff. A couple of other quick things, housekeeping things. I will be today's moderator, and I'll turn it over to Brett in a few minutes. And I will be monitoring your questions. So if you have a question, you can type it into the, I believe it's the chat area. Is that correct, Brett?
No, it's for the webinar, it's the question area, Rich.
The question area, okay. So you can put that into the question area. And I guess part of the challenge right now, Brett, is that I don't see all of the attendees on my list. If I'm going to be, yeah, you might have to make me an organizer.
Oh, okay.
Well, while Brett's doing that, I'll continue chatting here in a second.
Should be all set now, Rich.
Okay, that changes the, that looks better.
Okay.
So right now, just to make sure that you can hear us and you can see Brett's screen, if you could just click on the wave your hand, and that, I see a couple of hands waving. Excellent. So you can see us and hear us okay. All right. And then again, let me repeat, sorry for the technical glitch there, but if you do have questions, please type them into the question area. I'll be monitoring questions, and then I'll ask Brett to pause periodically so we can answer your questions in real time. So I believe I've covered all the major items, Brett. In a few seconds, I'll turn it over to you. Brett, why don't you take it away and tell them a little bit about yourself, and we'll get started here.
Thanks, Rich. I appreciate it. Hopefully you all already know me, but probably not. My name is Brett Zerba. I'm an applications engineer with Taco, and with the company roughly 25 years. And Rich and I work together quite a bit on our presentations. And unfortunately, or fortunately, we've been doing it since March now. Imagine that, Rich. Oh my God, March or April. That 2-week lockdown has turned into a little longer than that. But,
well, the good news is, like, I guess we saw from the news yesterday, they're getting closer to a vaccine. That's great news.
That is good news.
Maybe 12 months from now, we'll be talking about, remember back in the days where we did all our broadcasting for remotely? So,
yeah.
Anyway.
I hope so.
I know.
One other housekeeping item, I just want to make sure everyone realizes about 24 hours after today's presentation, you'll receive an email, or you should receive an email with a link to the recording of today's presentation, as well as a link to a PDH hour certificate if you require that for your licensing. Just make sure your state accepts these certificates from us. Or if you have questions, you can always email us as well. So again, I'm a degreed mechanical engineer. I graduated from the University of New Hampshire in 1981. Imagine that, that's a long time ago. Whew. Holy moly, holy moly. But I've been, like I said, I've been at Takeo almost 25 years, and it's just been a total joy to work for this manufacturing facility, headquartered in Cranston, Rhode Island. But let's get into today's topic. This tool, first off, if you go to our website, right, there's some handsome guys on that picture right there. Oh my God, look how young we look. But if you do go to our homepage of our website, takeocomfort.com, and you'll notice there's a tab right here that says software. You click on the down arrow and you click on HSS Hydronic System Solutions, and you can download the software right from our website. And Rich, how much are we charging for it this week?
Well, for the hydronic solution software, there is no charge, so you can
It's
download
free
that for
again.
free.
Oh my God, it's
So
free again. And that,
yeah, everything that Brett is going to show you today is within that software package, and there is no cost. So you can download it, and then you can have fun with it.
and notice there are some videos here that help you learn the software, and a quick start guide that you can download as well from our website. So please be aware that they are available. It's a Windows-based program, and it does need to reside on your computer. Okay, so it's not a web-based program. It is a a program that has to reside on your computer. I'm not going to tell you Apple users, Mac users, to go out and you get a Windows program instead. But if you want to use it easily, you got to do some finagling behind the scenes on your computer. So it is a Windows-based program. So please be aware of that. And Rich kind of touched upon it a little bit. The icon for the version that you download from our website is the one hopefully you can see my bouncing red ball here. And if I put it up in the top left corner, that icon is what you would see on your desktop or in your file programs or whatever. And that's what you would click on to open. The company who wrote the software is actually HVAC Solution. We're their partners now, and we offer the hydronic version to the industry. And again, anything I show you today, you can do with the hydronic version. Hopefully everybody realizes that Takeo specializes or sells product in the hydronic HVAC market: pumps, tanks, heat exchangers, and other pieces of equipment. But for HVAC hydronics, okay? But obviously, HVAC also has other methods for distributing BTUs around a building: air side type systems, steam type, domestic, and maybe some others over here. I'm not even going to say their initials, but nonetheless, the software company, HVAC Solution, sells a professional version that allows you to design airside and steam and other type of systems. So go to their website if you want to get more information on that. But again, I'm not anything I show you today, as Rich mentioned and I mentioned, you can do with today's with the software you can download from our website. The software package is very, very intelligent and very easy to use. But what it provides for us from a design standpoint it is a lot of information, relatively easy, very easily. So look, let me get my little bouncing ball again. Us pump manufacturers and our reps and you folks, engineering specifying folks and whatnot, you need to specify the flow and head of a pump. Well, there it is, shown right here on this drawing. There's the expansion tank sizing. At one point in time, Rich and I, Rich mostly did a expansion tank webinar, how to size expansion tanks and keeping track of the volume of the system, piping volumes. We get questions on piping volumes all the time. Well, this software automatically keeps track of that for you and helps size expansion tanks. And again, the pipe diameters, it displays pipe diameters very, very, very quickly. And I'm going to show you all this. I'm just kind of showing you an example here. And then I actually like it because it's very colorful, right? Most of us, if not all of us, can tell this is a hot water system because it's red. Red for heating, right? That kind of makes sense. And it provides a nice layout with a lot of information on one drawing. I mean, I'm representing a 4-story building here with some supply and return, maybe a hotel, Yep, this is a hospitality example. So, you know, I'm running down the hallway with my piping. The contractor knows he's got to run this down here. We could put some room numbers in these coils, and boom, look how easy, and all that information is shown for you. So it's this software package. For many years, we called it, the nickname was AutoCAD on steroids because of the calculations it does for us. In order for it to do the calculations, we, the user of the program, need to put in the loads of these coils. So in this case, and I'm going to show you how to do all this. It's very, very easy to do. In this case, they're all the same, roughly 9,000 BTUs. Okay, so you have to put in the loads for those coils. And we need to put in pipe lengths. And once we do that, the software does a bunch of calculations very, very quickly, and we can manipulate or improve those calculations. And I'll show you what I mean by that as we get into today's presentation. So here's a heating distribution system. If I go up to Windows and click on project 2, sooner or later I'll get the right one. Here's a chilled water example, right? I think most of us, again, could tell it's chilled water because it's blue. Excuse me. And there's a icon that represents an air-cooled chiller, but the same information is displayed here. And trust me, if you become familiar with this software, you can duplicate this drawing or duplicate this design very, very quickly. But watch this. Right now, I'm showing what, 100, just over 190 GPM and around 66 feet ahead. Well, watch what happens if I delete a whole. I mean, how many times on a project, maybe during installation or up front, things change, right? Half our life we deal with changes from a design standpoint. At least it seems that way. Watch, if I hit delete, there goes the circle. It's not even the circle of death. And then I just recalculate. There's that circle again. And I zoom in on that pump. Look at that. It's already resized the pump for us virtually at the click of a couple of mouse buttons. So think about that from how you can utilize this program very easily. So Windows-based program, let's get started on designing a couple systems. We're going to have some fun today, hopefully. So file new, like I said, it's a Windows-based program. So hopefully a lot of these tabs look very familiar to you, if not all of them. I'm sure some are different, but nonetheless, they kind of make sense. The hydronic version, right? I suggest you stay in the compact tab and hydronic tab, or compact hydronic 2 tab. These are the 2 tabs I spend most of my time in. And you can see me toggling back and forth. So if I click on this one, well, let me get that other sheet of paper here. So I just got a new sheet of paper, right? File new. I could have went file new, but I had already had it opened. So if I click on this one, I can put my cursor on any of these pictures, any one of them, and it tells me what it is. Hydronic boiler. I can click on the down arrow and look at all those boiler manufacturers' names in here. So that means their equipment's actually embedded in the software, their selection equipment. But here's how I click and drag and drop a component on the screen. Very, very easy to do. So let's play that game again, and just to make sure people, there's heat exchangers. I'll put a plate and frame heat exchanger on there. I like putting Taco equipment on the screen. You know, that's and then here's a vertical inline pump. So you can kind of see how easy it is to put pieces of equipment on the screen. And then if you use this software or any Windows program, you got to love the undo button, right? You can undo it and get rid of stuff. That's how you drag and drop components onto the screen. So these are the kind of the major components for a HVAC hydronic system. Over here under the hydronic 2 tab are more valving, like a control valve as an example, maybe a strainer, a hydronic strainer here, maybe some type of fluid indicator or something to that, fluid sensor. I think there's even an air vent around here. Yep, a relief valve, air vents. So there's all different types of you know, fittings, I guess, or whatnot, so that you can kind of fine tune your design if you'd like. So just keep that in mind. So you can build a project, and we're going to build one, but let's go have some more fun. If you click on the wizard tab, hydronic, look at, you have some choices here, right? So this one here, you could actually build a whole system, and we're going to do that, or just a loop, and I'll explain what I mean by that when I build a system. But if we click on this one here, generation, watch this. Let's answer some questions. So let's do a heating only system usage, right? So I'm going to build a mechanical room for a boiler room, and I hit next. Well, flow direction to the left, that's fine. I'm not going to change that. So notice the heating source. Most of these, I mean, you know, it doesn't default, but I got to choose boiler. But you notice you can do a air to fluid heat pump, heat source sink. So, you know, you have some options there, but probably for most of your applications, you'll choose a boiler, and I'll hit next. Let's put in a couple of boilers here. And if you wanted to use a specific manufacturer, you could in your design, but I'm just going to keep it at none. We'll talk about load portion in a few minutes. Fluid type, right? Fluid type. And we all know, based on hopefully our experience or some of our other webinars or other webinars you've sat in, that it's very important to put in the right type of fluid if in fact it needs to be put in there. Glycol probably is the most used one in our industry, but I'm just going to leave that alone. And condensate neutralizer, so it does default in a condensate neutralizer, so I'll let that sit there as well. Hit next. The distribution piping, right? How you want to do your piping coming off the boiler. Let's do manifold primary for this one, and this explains it over here what each one is. But you could, if you spend some time on that going through these, you could see how they look a little different. Hit next. I'm going to put in 3 pumps. Maybe you know what? For the first example, I'll put in 2 pumps at 100%, so I have a dedicated standby. And I'm going to show a vertical inline. That's the Takeo KS model, but you know, you have other choices here, and so probably most of our designs would be the vertical inline, close coupled, or not split coupled, or the horizontal frame mounted end suction. That's the Takeo FI model. But for for this first one, I'll use a vertical inline. Hit next. I'm going to put some valves on it. That's fine. I could get rid of some, but nonetheless, I'm going to leave them there. Expansion tank, right? We've had some seminars on expansion tanks, and this is what I call the Cadillac, right? The vertical bladder full expansion. So that's our CA model. You have some other choices there, but I like to default to that full expansion for my design. And then the air separator. This is going to be that inline one that we've talked about, or hopefully you know some information about. The coalescing type, very, very efficient, and whatnot. But watch what happens when I hit finish. Boom. Bingo, bango, bongo. There's a mechanical room drawing done for us very, very quickly, right? And you can kind of see there's no loads in here, so the pipe is black, and there's some zeros on here, but you can see the layout that I'm showing here, right? I have a couple of boilers. There's that air and dirt separator I talked about. There's that expansion tank. It is starting to size that expansion tank, and I'll explain that in a second. And there's that pump showing flow and head. For my lead lag. I think our industry, or hopefully some of you understand the lead lag concept or conversation that we could talk about. So there's a quick way to design a mechanical room. All right, so maybe it's early in the job, and I don't know a lot about the building, but I do know how big the building is. You know, it's not unusual to have an idea of how big the total load's going to be. So watch this. If I go over, I went back to the compact hydronic tab, in this red icon, I click on the down arrow, I go to building, and I can get a picture of a building. So let's just do a office building today, and it's really just a picture. It doesn't say anything, but nonetheless, I can drop that on the screen, and now I can draw a pipe. So you need to learn how to connect the components to draw the pipe. Now, the software did it up here for us automatically, but sooner or later, you're going to have to draw some pipe. This is the pipe drawing icon right here. But if I take my cursor, I want to come out. Okay, I'm gonna, well, no, you know what? This is the inlet side, and I know this is the discharge here of the mechanical room. So I'm gonna start right here. I left click and release, boop, 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 boop. And every time, it's easy to change directions, left click. Drawing pipe is actually fun with this software. It's so easy, it's fun. So there's my inlet to the, coming out of the mechanical room into the building. And here's my return back to the mechanical room coming out of this office building, right? Pretty easy to do. So hopefully, if you get a chance to use the software or take a look at it, you'll pick up the drawing pipe very, very quickly. Let me just undo something here. You just got to be careful. You got to make sure the cursor changes to that, and you start with that little tab or that little arrow, left click and release. And then you just got to make sure you get to that tab. There's no arrow here. Like if I click here, it doesn't get there, right? So I got to make sure I'm touching that until it connects in, and then it's pretty easy to do. And then I always recommend to get rid of the cursor or not get rid of it, but change your cursor back to your normal one. And I just right click on my mouse. I do recommend you use a mouse with this software. It's a lot easier. And if you have a roller, you can kind of play with it. You can kind of zoom in very, very easy. So now that I made a connection, I can add the load and watch what happens. I'll go over to this icon. I click on it. I actually double click and I bring up the property box of that load, okay? And here's everything on the screen has a property box. And this is where you put in the information or access the information, see the information associated with the components on the screen. So you can kind of tell it's asking for a load. It's hard to tell, but if you look at the screen closely, it's actually blinking right here. So maybe I know that this is a $2 million. You got to count zeros. I don't think I counted enough there. BTUs, and you don't have to put in units. And watch what happens when I hit OK. Boom, bingo, bango, bongo. Look how quick it starts doing calculations for us, very, very quickly. I mean, it's pretty amazing how quick it does calcs for us once you start getting used to utilizing the software, right? So quick, you couldn't even believe it. I just got to check something out here. I wonder what's going on. So you can see it's starting to design that pump for flow and head, right? So there are default values in here. And what do I mean by that is if I look at this imposed load, right? Key data, component head loss 5 feet. So if you sat through, or if you realize how to do system resistance calcs, or somebody in your office does them, or you do them, or you estimate them, or whatever, it has to have some pressure loss as it goes through this building. Well, I'm going to estimate this as I'm just putting in a different little higher number there. Maybe I'll put in 30. And watch what happens to the head loss on the pump when I hit OK. It jumps up by that amount very, very quickly, as you can see. So that was pretty amazing. Rich, do we have any questions? I'm kind of jumping around here.
We do. We actually do have a question.
All right.
Let me bring it up here. The question that popped up was, here we go. First question, can the P&ID be exported to a DWG format to drop into other drawings?
Awesome question. The answer is yes, and I'll show you how to do that. It can be, let me make sure I answer that question correctly. And I'm going to go through this process right here. You can save it as a schematic with a .dxf into AutoCAD. So hopefully that answers that question.
Yeah, I think it did. If we have a couple of minutes at the end, Brett, we'll turn it over to me and I can open it up. I have AutoCAD on my computer.
Yeah.
So the next question is, as for the waterside delta T, is this integrated with the energy code for design issues like delta T? And I don't know if I know the answer, but I do not believe that the delta T is customizable. In other words, we can pick any value we want, whether it complies with the code or not. I believe that's true. Is that true, Brett?
Yes. So currently it's not tied into that. to the code that you brought up. But I just brought up the property box of the boiler, and you can adjust the delta T's here or over here for the loads or any place you want. So you, as a user, you have the ultimate flexibility to control those values as required. So hopefully that answers that question. So it does require some manual work on your part to get to that answer.
Yep, sounds like good answers, Brett.
Oh, good. So back to our little drawing here, and notice, right? Keep in mind that we don't have any pipe lengths in here, and we'll take care of that when we do another one. But watch this. Now, here's how easy it is to display pipe diameters. Very easy. You can draw a box. I need to activate the whole drawing. I could do that by drawing a box, or I can hit Control A on my keyboard. Notice when I hit Control A or drew the box, when I say it's activated, you see all these green grippers. Now I take my cursor and I right click on my mouse and I go up to Connector Annotations and I click on Diameter, and there's some diameter. There's diameters shown for the piping, and we're going to look at the details of that. But from a pipe sizing standpoint, that was pretty easily done. So hopefully you can find some uses for this software, presentations or whatever, but you can get to this point very quickly, as you can see. If I click on this piece of pipe here, or any piece of pipe, it shows you how it's sizing pipe. And we have Rich and I, Rich mostly does presentations on how to manually size pipes or do head loss calculations. And there's charts out there that you need to use for velocity and how much flow through each piece of pipe. Well, all of that information is built into the software, and based on this flow, in the maximum unit head loss and the maximum velocity, it has selected a 4-inch diameter pipe, and those are the values it's using. But again, similar to all the other flexibility you have, you can change those values as well. To me, they're pretty standard numbers. Maybe that unit head loss is a little low, but you can change that. Let me show you what I mean by that. So I want to change that maximum unit head loss for all the piping. If I hit Control A and I right click, this time instead of connector annotations, I'm going to go to Property View, and I'm going to, what do I want to globally change? Well, I want to change the pipe. So if I click on pipe and I hit Edit, notice I have access to all of the pipe now, and I can change that to 4 feet per 100 instead of 3.3 feet per 100. It didn't affect any of my calcs, but nonetheless, I just wanted to show you how you could make a quick global change, as easy as that was right there. Anyways, the other item that is important to understand, and again, if you've gone through our manual calculation class, you know what we're going to talk about here. We need to account for fittings in a piping system, elbows, T's, and other components where the pipe changes, right? I'm sure most of us, if not all of us, have been on job sites, mechanical rooms or whatever, and it's amazing how many times the pipe changes at an elbow or whatever, and all different types. Well, what the software defaults to is a fitting factor. So watch what happens. If I type in a length here for that piece of pipe of 200 feet, here's the head loss for the pipe. It's going to multiply it times 1.5 and give us the head loss for that piece of pipe total. And watch the head loss on the pump. When I hit OK, it has jumped up by that amount. So there's how easy it is to take that into account. If you get familiar with the software, you can actually count fittings and whatnot. But I recommend you use the fitting factor, at least initially, or whatever. That's really up to you. Again, it's user based. So, but please feel comfortable that information is all available here. Rich, I'm trying to shut off the Teams thing, and I can't. I don't know what the heck happened. I thought I closed it down, so like we keep getting those pop-ups, and I apologize. But nonetheless, watch what else you can do here.
So Brett,
If you want,
a question did pop up,
awesome.
which I don't think I've seen this question before. This is great. Does
Uh-oh.
the software specify the insulation type and thickness?
It does not. It does not do anything with insulation. It's so that is not something that it does currently. So it's just the pipe material. Matter of fact, let me show you that under hydronic, no, under construction, right? So I'm in the, let me make sure I define it correctly. I'm in the property box of a length of pipe, and you can tell which piece of pipe it is because it's yellow right now. So I bring up the property box, and if I click on construction, you can see it has all different types of material of construction for the pipe, and you can change it per pipe, per diameter and whatnot. But nonetheless, it does not take into account insulation. So keep that in mind. But great question, though. I'm glad someone asked that. But you're right, Rich. That was a newbie. That was a new question for us.
Yeah, excellent. Thank you.
So here's a quick mechanical room design, right? And think about what you could do now, right? You can start the process or have some conversations or whatever, maybe for a presentation, or whatever. So very, very quickly, you can get a head start on a project, possibly by using the wizard. Or if you use the wizard and I go to hydronic again and I click on system, maybe we can design a whole complete system. So let's choose what kind of distribution. Well, we'll choose direct return two pipe. Let's choose a cooling only for this application. Number of loops. So what that is I liken it to how many vertical risers you have or horizontal distribution loops. So say it's a 4-story building, right? And my mechanical room is going to be down on the first floor. So I'm going to have distribution on 4 floors. So I would type in 4. And again, you can show them vertical. In this case, I'm going to show them horizontal distribution. And I'll put the mechanical room down at the bottom left. And the flow direction will be up and to the right. Hit next. So I'm going to put in maybe 6 loads on each floor. And you could change that per floor, but nonetheless, I'm going to just show 6, and I'm going to hit below. So it's going to show the piping, the loads below the piping. And this is where you choose what type of load do you want. And whenever I use it just for hydronic design, I choose impose load, and then I pick out what icon I want. So maybe I just want a coil of some type. I'm going to represent coils. And notice you have a bunch of choices here. But nonetheless, I'm going to choose coil. I'll hit next. 2-way control valve on the discharge. You can put in 3 ways or some other alternatives there, but nonetheless, I'm going to leave that alone.
Hey, Brett, we just
Yeah.
got a great recommendation from someone in the audience. They said, Brett, on your Teams tab, it says, Brett, change your team status from available to do not disturb. Click the circle with the green check mark to change. We're learning stuff from the folks in the audience.
I don't know what people are telling me where to do it, but I don't know where that is.
Well, we'll continue along. Maybe someone has another quick pointer
Yeah.
for us. But,
Thank you for all your help, folks.
yeah, thanks.
I'm just not smart enough to. Anyways, hopefully that'll help. That didn't help either. Okay, so back to I'm going to put in some information here. Maybe these are air handlers. And what's the load? Remember I said we have to put in the loads for helping. So I'll put that in. Maybe I'll use an air-cooled chiller just so we can get through this presentation. Notice you have other choices here, water-cooled chillers and a cooling tower, just a cooling tower, all different types of choices here. Heat recovery, air-cooled chiller. Hit next. Let's put in a couple chillers and whatnot. Hit next. Maybe I'll just show you primary, secondary for this particular choice, just to show something different. And the primary pump, that's the pump attached to the chiller. This time I'll put in a couple, but I'll show you a different, I'll show you the frame mounted end suction just so you see something different. Expansion tanks, next. Air separator, By the way, let me just show you something, because this happens if you use the wizard, and it still happens to me. If you answer it, if you answer a question incorrectly or don't answer the question, so watch, I'm going to change that 1 to 0 and look down below. I can't toggle to the next screen. So if you're ever in the wizard and you can't toggle to the next screen, go back up and look at your answers or to the questions or whatnot. Something's amiss up above. Okay, next. Air separator, hit next. I don't want to save that. I'll hit finish. And look at that. It has drawn a complete system for me very, very quickly, right? And these dotted lines, if I zoom in, these dotted lines are a sheet of paper. So what I might recommend you might want to do is change it so it's all on one sheet of paper, so I can go up the file. Unfortunately, I have to go kind of a roundabout way here to do it on mine. All the smart people in the audience will do it much smarter than me. And now notice I have it on I think I did a B-size sheet of paper. So now it's all on one sheet of paper. Pretty, you may want to do that before when you start a project. But now I've got a complete 4-story building with 6 loads on it, a couple of chillers. I'm doing primary, secondary. So I have a primary pump attached to the chiller, each chiller. And then there's my secondary or loop pumps or building pumps or whatever. And then how do you display pipe diameters? Control A, right click, connector annotations diameter. There's my pipe diameters displayed for me, very, very quick. Now you got to start thinking about your pipe lengths or changing some loads or whatnot, but another head start. And trust me, if I can do this by answering some questions, any one of us in the audience, it's a process that's very, very doable as you get into it. So please keep that in mind. And you can see I labeled these all air handlers. I do want to show you this. If I bring up the property box of an air handler and I click on description, you can override the description of that. So maybe I want to call this one just coil instead, and I hit OK. So now you can see that it changes that to the word coil. So it's really up to you what you want to call them. So you have that ultimate flexibility with the software as well. So you can have a lot of fun with the wizards, or you can just draw a system the old-fashioned way, but by putting pieces of equipment on the screen. So let me, as I'm working here, I'm just going to quickly do that so we can get one done, and I can mirror it, and then I can go over here and get some coils, and that's right. I want to get maybe I'll get a fan coil, and then I can copy and paste that very quickly, right? I can build it all by myself, right? I don't have to use the wizard. You have that flexibility, and trust me, I'm 61 years old, so a lot of the folks in the audience are much better at using software than me. So you want to make sure you come out, or if I can pick this up, any one of you folks can. It's very, very easy to use with the wizard or whatnot. So I'm just drawing some pipe here, and I'm yapping as I go. And there's my return piping. We get this question every once in a while, and it's a great question. But see that I wasn't careful enough. I didn't get out all the way out to the piping. You need to be careful with you need to be an HVAC engineer in order to use this or you should be a well-trained HVAC engineer to use this software. And I say that because it doesn't tell you when you do something wrong. So say you put the expansion tank on this discharge side of a pump instead of the suction side. It's not going to give you a warning that that's not the best location for that. So you do need to have that knowledge to get the full benefit of this software package. You can see I copied and pasted some loads. I aligned them up. Now I can I can go onto this load here. I can hit the key data tab, and I can type in a value here, and maybe I can change that description again. This is maybe AHU-1, and I can hit OK with that. So I put one load in at a time. I can put 3 loads in all at once. Very easy to do. So maybe these are AHUs -2s. And then I could put key data tab here, and these are, I'm just making up some loads here, obviously, and hit OK. Or I can click on this one and I can hold the shift key down and I can click on this one. So now I can put in the loads for every other one on this screen. And maybe these are, I don't know, FCU-A's or something. I'm just showing you, I'm just kind of giving you some ideas of what you can do with the software very quickly. So again, putting in loads becomes tedious, but it's pretty easy to do once you get used to it. I don't know, coil, and maybe these are, and hit OK. So now I put my loads in. Now I'm going to build my mechanical room, right? So again, you know, do you want to pipe away? Do you want to pump away from the boiler? Do you want to pump into it? That's your decision. The software is not going to tell you which way to do that. Please keep that in mind. So I'll just go down here and I'll get a vertical inline pump, and watch what happens when I get it close to the piping. Once it turns yellow, it drops in and it starts to size that pump for flowing head. And then I can copy it and I can paste it, and I can put a second one up here, and then I can connect these in. So this is my traditional lead lag, where each one's designed at 100%. And then I'm going to go get an air and dirt separator. You folks may, God dang it, I do that every presentation. You would think I'd learn. You folks may be used to that picture there, where it goes, the vortex type, where it goes in high, swirls around, and comes out low. But really, talk to your TACO rep, or go online, or listen, sit in if we do an air and dirt separator one. Really consider specifying these inline ones. The piping's easier, and they are a lot more efficient at removing air and dirt. And we all can do, install a better system if we can get a lot more air and dirt out of these type of systems. So please consider that. And notice when I drop this in, let me undo that again. When I dropped that in, it went from, so when I hit, watch what happens when I hit redo. I love playing with the redo button. It went right back up to 20 feet. So it added 6 feet of head loss for that component once I dropped it in on the screen. And let's see, my expansion tank, I can get the Cadillac again, and notice I can make the picture a little smaller, fits a little better. I get the yellow tracer going on, and there are default volumes in the system. Very quickly, now I'm going to start putting in some pipe lengths. So maybe I'll, just to get something in here. Key data, I'll put in 10 for those. I'm just putting in some numbers, so we have some numbers in here. You know, I'm not spending a lot of time doing that. Any one of us will come up with methods that might be a little more advantageous for how you would put in pipe lengths, but nonetheless, you do need to put in some pipe lengths. And every time I do it, it does change the head loss on the pump. As you can see, let me do another one here. This will probably be my last one. And that head loss on the pump, it does a tally sheet for you very, very quickly. Pipe diameters, Control A, right click, connector annotations, diameter, boom, there's our pipe diameters displayed for us. Remember all the faults we have, you know, pretty straightforward there. But boom, look how quick you're able to do this. You can do it manually or use the wizard, right? You have total flexible options out there. And then if you want, I always like to show people that you can, you know, make your design look as cute as possible, or as finalized as possible. I can drop in a control valve right here, and maybe, let's see, I got a balance valve. I could put a balance valve in, maybe a couple of shut-off valves. Where are my shut-off valves? Nope, I don't want that one. There's some manual valves here, maybe an air vent. I could drop that in here, and you can actually add notes to the drawing, right? So I could type in typical. And I could put typical here, right? Yeah, it's 30 places, 20 places, whatever you want. So you can get some ideas there. Pretty easy. Rich, any questions? How are we doing question-wise?
Yeah, we have a couple that popped up. So the first one, and I don't know the answer to this, can you get equipment IDs to auto-populate in a sequence? For example, FCU1, FCU2, FCU3 by just selecting a group of equipment as opposed to typing them individually?
Awesome question. So let's see if we can work some magic here and answer that question properly. So if I go back to the description and I uncheck ID and hit OK, let's see what happens. So they all went back to the original call out, IHL-1. So if you want to number them, so let's say we want to call them all fan coils and sequentially number them, you have to override that IHL-1. You do that by bringing up the project property box. And normally when you get into this box, you would be in the description tab. Okay, and let's see, if I scroll down to, is it callouts? Yeah, so I'm in the project property box. You can see I can name it, you name the project, select the state, but watch, if I scroll down to hydronic and callouts, it gives me access to all of those callouts. So now I just got to search for that IHL-1. All right, how come? You would think I'd know what I'm doing here. I'm sorry, prefix names. I'm sorry. The call outs are for the hydronic stuff. Prefix names. You want to go down to prefix names. I apologize for that mumble jumble. And notice I find the IHL-1, right? That's what it says. I click on that and I override it. So I can write at FCU. And let's see, drum roll. Bingo, bango, bongo. There you go, right there. So you would have to do that there if you would like it to sequentially number them. So hopefully that answered that question.
I think it did. There's another question.
Yep.
I'm going to read this to you, Brett. We may have to go back and kind of, let's see, how smart is the software? And by that, I mean using expansion tanks as an example. Yes, it calculates the volume, but I assume the software doesn't know the height of the building, etc. This software could be useful for sizing expansion tanks, the volume, but does not take into consideration other effects. But I think it does. So I'm going to let you answer that question.
So great question. I'm glad you pointed that out. Thank you. If I go to the expansion tank and double left click on it, I apologize. I probably should have explained this. Yes, it has a volume summary in here and it shows you all the volume of all the components right under summary. But over here, here's the actual other information that it's utilizing to size the expansion tank, the static head above the tank, relief valve pressure. So there's some values in here you may need to change to take that into account. So correct, you are correct in your statement that it doesn't know the height of the building, but you can define that very, very easily by putting that information in. So hopefully that answered that question. Do you have any more to add to that one, Rich, on the property box?
No, I think that, yeah, that's great information.
Yep.
Let's see if anybody else has a question here. No, Todd said very cool. Oh, one just popped up, Brett. Does the program create equipment schedules? Ooh.
Oh, yeah. We're getting right to it. The answer is yes.
Yes.
And I'm actually going to show you how very, very quickly. But before I do that, I do want to show you one other. Rich and I use this quite often when we're utilizing the software. If I double left click on the pump, and again, it has a summary of the head losses, so you can see that in here. But if you go to the key data tab of the pump, it says show head loss path. So I like to make sure when I'm working in a more complicated system that I'm comfortable that the calculations being displayed on the software and that it's calculating is the path that I would have expected it to be following, right? I usually you have an idea, right? Please make sure you use this tab to feel comfortable. This is a very straightforward system, right? And you could tell which one's the longest run or the most pressure loss because I put some components on there and whatnot. But in a more complicated system, you got wings to the building. Utilize this to make sure you're comfortable with that. So that's my recommendation, but it's very, very easy to do, right? Hopefully everyone can see that. So now that we created our drawing, and we have a nice P&ID drawing. It displays things. This software will select equipment for us as well. I think somebody must have known that because they put a nice softball over the tennis court. Anyways, any component that has that shading is selectable. Notice I did that with all the green pieces of equipment. God, how did I ever choose green pieces of equipment for this project? Anyways, if I click on a pump, and I can go to the word selection, and I can hit select, and it starts to select pumps for you. You can start to look at different information here. You can actually go see a curve. You know, if you remember some of our presentations on where you want to be on the curve. This is a very simple curve. It doesn't show all the information that it would if you went to our website with the selection, but nonetheless, it does give you some ideas about that. So you can utilize the software to select equipment. So watch what happens to the shading on these 4 pieces of equipment when I hit the global select or select equipment. The shading's gone away. That means that those equipment pieces, have been selected for us. So if I click on selection, you can see it's selected that component there and all of the other pieces of equipment. So any equipment that is selectable by the software, you can select by utilizing that or each one separate. So now that I've selected equipment, maybe I want to create a schedule or an AutoCAD drawing or something. So if I need to tell the software what I want it to create. So if I go up to File, Coordination File Options, it's kind of a weird, I always get confused with the words, but once you get used to it, you'll understand because they are file options and blah, blah, blah. I don't know why they came up with that. Sometimes mechanical engineers that try to write programs. Anyways, it brings you to, oh, let me do that again because I already messed up. File, coordination file options. It brings you to the project property box, to the coordination file options screen. And look at, you can create any of these files, a bill of material. So if you had for a contractor or whatever, if you had a good idea of your pipe lengths, you can get a bill of material in there, and that could be helpful for costing or pre-ordering or something to that effect, or allocating pipe for your project. So the question was asked about equipment schedules. So I'm going to choose equipment schedules, and I think we'll have time, Rich. When I'm done with this, I might have AutoCAD. They may have downloaded it. Let's see if it works. So anyways, I'm going to choose equipment schedule. You can save it as a DXF. I'm just going to use an Excel, and I am going to try saving the schematic as that as well. So I hit OK. Now all I have to do is save my file. File, save as. I'm saving it the long way. I'm just going to leave it as project 4, save. Once the circle of death goes away, oop, it came back. Go away again. Okay, it's gone now. Those files are created for us. If I go up to File, Open Coordination File. If you didn't do it correctly, this would be blank, but I did it correctly, so I can click on Equipment Schedule. And here's a equipment schedule done for you with an Excel spreadsheet format. There's my air separator and the other pieces of equipment. Some of it's not I didn't select, but there's those 2 pumps there, so you can see that stuff is been selected for you. Pretty straightforward. And let's see if it opens up, Rich. Let's see if my AutoCAD. I think I have a viewer, so it might open up. It is a layered drawing, so you can bring it up. Hey, it worked. So you can save it as a DXF if you'd like. And I actually see in some MEP drawings now, I'll see a layout like this in their MEP. So it'll be one of your sheets in the MEPs because, your package that you do. Because a lot of times the piping layout, maybe you'll see an ISO of it or whatever, but a lot of times you got to go from sheet to sheet to sheet to sheet. Well, if you have a layout like this, you can, maybe have it all under one sheet. That's something to consider in that regard. Here's something, this is a little advanced, but it's something to think about. A lot of our projects get complicated, okay? And we have a lot of floors. you know, or whatever. Each floor has a lot of loads, and maybe you want to show the loads a little work. So one of the projects I've been working on recently, it's an it's a chilled beam project, but I just want to show you how I thought outside the box utilizing this software. So here is level 100, floor 1, level 100, and I actually dated it. So what I am showing here is just that floor's layout, and these are like I said, these are chilled beams with a low flow block. We'd have to get into that whole discussion, you know, and some other loads here. But think about it. And all I did was put a chiller and a boiler here so it would do the calculation, so I could size the piping, or the software would size the piping for us. So now think about it. If you did this for 5 floors, as an example, 5 floors, right? And you had a chiller on each one, those chillers, that information really doesn't mean much. Then what you could do is a riser diagram, right? So now, because sooner or later these pipes got to connect or be connected to the main chute. So if you do a riser diagram, now you've got this layout for each floor and a riser diagram. So again, it's a little heady, this conversation, but nonetheless, it's something to consider if you can think outside the box. And I have done that on numerous projects. So something to consider. I tell you, Rich, I am getting hoarse from talking. Any other questions?
Why don't you turn the screen over to me, and I'll show them how you can create not only the diagrams, but also the schedule sheets in AutoCAD.
Okay. I'm going to make Rich Medairos. I don't want to mute him because I like it when he talks, but I'm going to make him the presenter.
All right. So hopefully, Brett, you can see my AutoCAD light screen.
I can, Rich.
All right. So I'm also going to go over here, and you can see the HS2 diagram. So
Yep.
here's an HS2 diagram I created just for the purpose of showing how you can get the drawing. So it's just like Brett did a moment ago. Click on File, and then Coordination File Options. And if you'll notice, I already have it checked off here as Equipment Schedule, AutoCAD DXF format, and Schematic, AutoCAD DXF format. And I click OK, and then I save that. And now I can open up my AutoCAD. In this case, it's AutoCAD LT for my travels. Open File. And there's my schematic drawing. I'm going to open that first and show you what that looks like. So there's an AutoCAD drawing, just what Brett showed you a moment ago. Then I can also open up the equipment schedule on another drawing. And there's all the equipment schedules. So I'm going to zoom in. Let's see, let's just zoom in here. Where are the pumps, the pumps, the pumps? Yeah, there they are, right at the bottom. So I can zoom in, and like any AutoCAD drawing. And I've done lots of drawings with piping diagrams and with schedules and stuff like that. And this software makes that whole process extremely smooth and fast. So we have one final question, Brett, that popped up. And it says, what is the price of the full version of the HVAC solution software?
I would recommend, well, let's do it. Go to their website.
I'll go back here I'll go up here to help.
Oh, wait a minute. Oh, yeah.
HVAC solution website.
Oh, yeah, I forgot. You have it. Yeah.
And here's where you can, what we recommend, what Brett and I recommend is that if you want the full version is to use the free trial. See, it's right here in the middle of the screen. And I think you can download their trial version. I don't know if it's 30 days or 60 days, but that's easy enough. You can just download the trial version, try it out. And if you think it's something you want, what we recommend is you contact your local TACO manufacturer's rep, and usually they can get it at a discount. But if you go directly to HVAC Solution Software, you're going to pay the full retail price. But if you go to the rep that's serving your area, you usually can get the software at a discount for you. So yeah, check the website out and you'll find out the actual price. Oh, and someone asked, I missed this, but what version did you use for the demo? And we used the free downloadable version from our website. So
9.
everything that Brett showed you today is used for the hydronic solution. Is that correct, Brett?
Yes, there was yes, correct. Yes.
Another question that popped up, I'm going to let you answer this one. Can you insert floor plan drawings for building scaled accurate systems?
There is a you have to try it. There is a PDF import, but it doesn't. You can't use the lengths of the PDF import to calculate the pipe lengths. It'll just, you can start dropping equipment in where it goes inside the building or in the room or whatever. Keep that in mind.
So we're
Well,
about
hopefully that answers the question. If you go to YouTube and type in import PDFs, I don't like to show it because I find it's a little cumbersome from me. I find it's cumbersome to use, so I don't use it too often.
So we're just about, excuse me, we're just about at the end of our time period, but let me see. No, I think we answered the majority of the questions. We might have a couple that are hanging out there.
I'll make sure I answer anyone that comes up.
So just to recap what Brett had talked about earlier, we did record this session. It will be available roughly 24 hours from now. You should get an email with a link to download the presentation, and also there shall be a link for you to download a certificate so that you can get your PDH credits. Did I say that correct, Brett?
Yes, you did, Rich.
So with that, if we don't have any final last minute questions, Brett, did you want to say some final words before we sign off?
Yes, thank you so much for everyone's time. We know how valuable that is, and really appreciate you putting up with Rich and I for another hour. And thank you so much. And great questions. Like Rich and I always say, the more questions, the more we all learn. So thank you very much. Go ahead, Rich. Take it away.
Yes, I'm going to echo what Brett said. Thank you so much for your great questions. It made it very interactive today. So with that, we're going to sign off. Please stay safe out there and take care of yourself. Now, hopefully I can press the right button here and I can sign off.